Well, we will start with the next talk. My name is Eva García. I'm advisor engineer on the technical and assistance service of Polyolefins in Repsol. And our talk will go about polyolefins for additive manufacturing. Well, additive manufacturing is a technology that has raised a lot of interest recently, and there are a lot of news. There are a lot of developments on the industry. But first of all, we have to make a question: if it's really an appealing technology that allows you to build and design freely, rapid prototyping, why we don't see it on real market? We see just on early adopters, but not on massive scale. Well, there are some. First to answer these questions, I will go through a little history about our relationship with additive manufacturing. We started looking at additive manufacturing in 2012, when we first contact with the players and so on. And on 2012, what we see is just early adopters, researchers, but not really interested on the industry. It was 2 years after, when we go deeper, we make a state of art, we just seen technology by technology, that we are starting to see that big companies like printer manufacturers getting involved, are increasing having interest. And also we see the first materials going development. Well, on 2015, we started interacting with the ecosystem. We started prospecting which kind of technology will suit for our materials. We are producers of polyurethane, and maybe for us it could be an opportunity. In 2017, we started material development. And when we face a new market, innovative, really different of what we have been used to do, you need to build partnerships. You cannot go alone. For this trip, we choose the best partner, Recreus. Here is Ignacio, that is from Recreus, the startup we are investing on, and we are collaborating and developing. And let me invite you to visit our corner in 3D printing. You can see our FDM printers going on, some prototypes, and some samples. And now, in 2019, we are proud to announce the next launch of our first polymer for FDM for 3D printing. It would be a Recreus materials filament, but do it by Repsol and with the guarantee of Repsols. Well, we have talked about our engagement with additive manufacturing, but we don't have answer the question I raised before: why additive manufacturing is not yet an industrial technology like extrusion, like injection molding. Well, it's because it has to face several challenges. And what are the challenges of these technologies? We are talking now in fuse deposition modeling that are filament technology, but it will apply also to sintering, selective laser sintering, or other technologies involved in additive manufacturing. Well, now we are on prototyping and low volumes productions. But what we wanted is go to industrial manufacturing, is where the technology has to go and have to a space. But for this, what we need is increased productivity. If the machines, the printer, need to have most speed to allow better productions, to reduction costs, and be comparing to injection molding or extrusion or the other technologies we can find on industry. As we said, manufacturing speed of printers is one of the keys. Other are related with materials. When there are few materials available for 3D printing technologies, if we see the first material that were developed, we can talk about PLA. PLA was the first material for FDM, and why it was PLA? What people starting using PLA? Well, it's because it's easy to print. You see that. Really easy to print, but the mechanical properties of PLA are not good. You can have magnificent pieces, but not functional ones. As the technology is evolving, what we are facing is to build more functional pieces or objects, and we need other materials. There are other materials, but with maybe better visual quality, but also mechanical properties are a gap. And also there are really difficult to print. These are the challenges in material that have to be faced. Well, there are other technical aspects. Materials for 3D printing, if you see on the corner the printer, you see that FDM, what they do is building one layer of the material and on the top another layer one, and building in the vertical X. Well, even if your material is really good, you see the data sheet and says, wow, it's a really amazing material, it doesn't mean that your piece will have nice quality. The vertical adhesion between layers is key. If the material doesn't stick well, you will not have mechanical right properties. Other aspect is thermal properties. You have to face. Why? Because when you extrude your material, and if the M is just a little extrusion, you heat your material, you build your piece, your material gets cold, and most times it's a ring. If you don't design properly your material, what happens is the material is ring and curl and doesn't stick to the surface, and you have what we call warping problems. Your piece have not the right quality. Building adhesion surface and thermal properties are other challenges to face. Well, the conclusion, if you don't design specifically for additive manufacture transformations process, your material will not work. Is the reason because we are starting to develop, and in the last 2 years we have been working with Repsols developing materials for FDM. And why? Well, the reason for us is really clear. Because polypropylene, we choose polypropylene because it's the material most consumed in industrial way, with a 19.2% of consumption. Is the polymer most used at industry. It's present in every sector: building and construction, healthcare, packaging, mobility. They are all using our materials. If FDM or any additive manufacturing technology will go through the industrialization, has to go with polypropylene as a reference material. If not, it would not be. And that's the main reason why we choose to get involved in additive material projects. Now, we are proud to present our new product, our 3D printing polypropylene for FDM that will sell Repsols by Repsol. This product has excellent mechanical properties. It goes further than the other ones you can find on the market. And also, it allows to big, high-size pieces. It solves the problem to build in vertical one. Well, some data. We are engineers. We are proud of our product. Well, what we have done is to take 2 samples of polypropylenes you can find on the competence and or polypropylene. We have built the same testing materials and we have tested. What we found, the important one, if you pay your attention in flexural models, you can see that in the horizontal X, Y, X, you have 350, and our product is more than 800. 800 in a flexible model is a value that you can find in injection molding. The other ones are base leather. But what makes the difference is not the XY, is the zeta layer, the zeta X. Why? Because in the zeta, what you are testing is how the layers stick one to another and how functional is your piece. You see on the market 250, 200, and our product is more than 700. It's all the time next to an injection molding material, like you can find. It's why we are proud of our new product, because it shows really mechanical product and is closing the gap between the additive manufacturing and the injection molding. Well, but innovation goes not alone. We also have, and Recreos has developed a promoter, adherence promoter, that allows to guarantee a proper building surface. Because as I mentioned before, one of the problems is if you don't stick properly the first layer of your piece to the bed of the printer, what it appears is it curls. When you are building your piece, it curls and you have bad quality. With this promoter of adhesion, we guarantee that the pieces will be nice and properly built. And also, it faces and it reduces the thermal stress of the construction. Now, we are in clients testing phase, and we are coming soon for sale. Another time, I invite you to visit our booth with the 3D printing corner, and we will see it in personally. Thank you for your attention.